Okay, so we have already talked about how to find slope if I'm given a graph, if I'm given 2 points, if I'm given an equation, I can extract the slope from the equation. So now what we want to do is we want to look at those slopes, and would you believe me if I told you that I could tell if two lines were going to be parallel just by looking at their slopes? It's true. Let's take a look. Remember what parallel lines are. They are going to be two lines that are in the same plane, right? That never cross each other. So, what do you guys think is going to be true about the slopes of these two lines? You might remember from algebra. Anybody remember what's true about the slopes of parallel lines? They're the same. They're literally exactly the same. Take a look. Notice they're both going up from left to right. So in this case, it makes sense that they're both going to be positive. But if two lines just both have positive slopes, that doesn't mean that they're parallel, right? Look at these two. They both have parallels. They are both have positive slopes, but they're certainly not parallel. Those are going to cross. Okay, so it's more than just having the same sign. They are literally the exact same slope. Okay, so it's actually really helpful to see this on graph paper. So I'm going to make for you a line that has a slope of, I seem to like 1/3 today. So I'm just going to make a random line with a slope of 1/3. So I'm going to start anywhere I want. I don't know, I'll start right here. If I want to create a line that has a slope of 1/3, that just means I'm going to go up 1 to the right, 1, 2, 3, right? That's how I get that 1/3, up 1 over 3. I'll do it again, up 1 over 3. And now I'll just connect those dots. Look at this super cool new ruler I got. Look at this. So fancy, but you know what's hard? I got to do it this way. Oh, yeah. Look how nice. Clear, I can see through it. Nice, sharp, straight edges. So the slope of this line is 1/3, as we've already said. So turns out, ladies and gentlemen, if I create a second line wherever I want, as long as I also give it a slope of 1/3, the two lines are going to be parallel. What? Watch. I'll pick a random point. Again, you can pick it wherever you want. Who cares? I'll go right here. You can pick whatever you want. If I do the same thing, if I go up 1 to the right 3, I'm going to make a new line that also has a slope of 1/3. Up 1 over 3, up 1 over 3. Connect these dots. I am loving this ruler. The things you get excited about as a math teacher. There you go. Look at those two lines. They are perfectly parallel. Perfectly. And it makes sense that they are, right? As long as I'm going up 1 over 3, up 1 over 3 on both lines, they're never going to have a chance to cross each other because they have that same slope all the way throughout the entire line. So they're never going to come together and meet. Isn't that something? So yes, that is our first really, really, really big important point. So important that we're going to make fireworks, not just a star. I'm going to add some flare. Super important. Okay, we're going to have two super important points today. Here's the first one. Parallel lines have the exact same slope. And when I say exactly the same, I did the same thing again. I mean it. Like if one is 1/3, the other one has to be 1/3. If one is 2, the other one has to be 2. You can't have something like 4 and -4. That's not the same thing at all, is it? Those are two completely different numbers, right? Exactly the same. They can't be close. Exactly. There's no wiggle room here. All right. So I'm going to ask you a couple of questions. We're going to see how we can sort of put this into play here. You're going to see on your homework, it'll ask you, what is the slope of a line parallel, oh boy, parallel to. So here's what you're going to see. I'll be giving you an equation. We'll start off with a nice easy one. How about, I don't know why this is so hard for me to just pick random numbers. 5x plus 7. So when I am doing parallel, life is actually super easy because I just explained that parallel lines are going to have the exact same slope. So if I can look at this and figure out what the slope is, I know what the slope of my second line is going to be because I'm just leaving it the same. Right? That seems super easy. It is right now, right? And then we're just going to make it a little bit more difficult as we go. So here's what I'm going to look for. I'm going to ask for the slope of the original line. So I'm going to sort of denote it like that. So that's the line that I have right now. And then if I want to make a new line that's parallel, I'm going to ask you for the slope of the new parallel line. Okay, well, this one's really, really easy because you guys just told me how to find slope of, if it's in y equals mx plus b, I know what the slope is, right? Shout it out to me. What's the slope of this original line? You're doing that thing where you're all shouting at the same time, so it all just cancels it out. So it sounds like nobody's answering, but I know, oh, there we go. I got one in the chat. Yeah, that's just a 5, right? Because I'm just looking at the number in front of the x. It's already in slope-intercept form, so life is really easy right now. And it's still easy because if I want the slope of a line parallel, I literally just leave it the same. So it was 5. It's going to stay 5 when I go to draw the new line, right? So the slope of a line parallel to this would have the same slope of 5. All right, let's make it a little bit more interesting here. Let's do, all right, this one's not that much more interesting, but I don't know why my 3s keep looking funny today. I did the same, let me fix that. Oh my gosh, just making it worse. Oh boy. Okay, I can live with that. All right, so let me keep calling on people here. Let's see, I think, oh no, this is my pile of ones that I have not yet called on. Let me pick you all up. All right, what's the slope of this line? Ketrin.
Negative 2/3.
You got it. So what would the slope of a line parallel to that be?
Negative 2/3.
Yeah, you just leave it. Negative 2/3. Easy peasy. Okay, enjoy it while it lasts, because once we get to perpendicular, we don't get this luxury anymore. Okay, we gotta increase the difficulty here a little bit though. What happens when you have something like this? I don't know. How about 4x plus y equals 6? Huh. I hope you're not thinking, oh, isn't the slope just 4? No, it's not 4. Oh, geez, see how upset I got? It's not 4 because this is not in y equals mx plus b form. So just like you did last night, you have to rewrite this first. You don't know what the slope is yet until you rewrite it. So how do I rewrite it? How do I get y by myself? Y by itself? I'm just going to have to subtract this 4x, right? So that's minus 4x and minus 4x. So now I'm getting somewhere. Take that negative 4x, stick it right after the equal sign, and then I have the plus 6. Now I can answer the question, right? So my original, I can see, is just going to be, oh, I got it in the chat, negative 4. Yep, don't put the x on the end, though. Remember that? So just leave the x off. You just want the number. Okay, yeah, but it's going to be negative 4. And then parallel. We love parallel because it's so easy. You just leave it the same. That's it. Miss Sabia, surely this gets more complicated. I mean, not really. For parallel, no. If you could do what you did last night on last night's homework, if I can give you any equation and you can extract the slope from it, you literally just leave it the same for parallel. Let me give you one more example that's a little bit trickier, but I mean, you know how to do it. I know you know how to do it because you did it last night. What if that was your equation? I still want slope of a line parallel to it. So I'm still going to start off by finding my original slope. And then I wanted the slope of a line parallel. Yes. Oh, I got it in the chat. Yes. Oh, my gosh. And it's right. I'll give everybody a minute to think on it. And I'll give you a hint. If you think that the slope is 6, I'm sorry, but you're incorrect. It's not 6. That number actually right there is completely irrelevant. It doesn't matter with anything. It matters when I graph it, but I'm not graphing them, so I literally don't care about what that number is. That number, it could be I don't know, it could be an ice cream cone. It doesn't matter. I hope what's going off in your brain is, I can't put this into y equals mx plus b form, so it must be a Hoy-Buck situation. Yes, it is, just like it was last night, right? If I don't have an x and a y, that's how I know to go to this. And then you're looking and you're like, oh, it's y equals, so the slope is 0. Yes, the slope of my original line is 0. So, guys, the slope of the parallel line is still 0. It doesn't change. I literally want the exact same thing. So even if I had done this example real quick, say it was x equals negative 2. Oh, did my camera freeze? It sure did. Sorry. Take a breather. I think I have the jitters. I think I had too much coffee today. I feel jittery. I don't usually get them, but I did kind of treat myself. We bought cold foam. Did you know that you could buy it in the store? Just like whipped cream. But it's cold foam for coffee, just like you get at Dunkin' Donuts. You can buy it. And it just elevates your drinks. They're so tasty now. But anyway, all right. So now I'm overindulging in coffee, and it's probably not the best idea. All right. Any hoosers, we're here. We're looking for the original slope and the parallel slope. What's the slope of this thing? X equals negative 2. Hint, it's undefined. Not negative 2. Yes! Oh my gosh, undefined. So the slope of something parallel would be?
Same thing.
Same thing, undefined. All right, guys, easy peasy. With parallel. We love parallel because it's so simple. I just leave it. Everything's fine. Okay? Don't forget that, because now we're going to throw in perpendicular and things are going to change here. All right? Let's try it. Before we can even talk about perpendicular lines, we have to remember what in the world they are. Do you remember? Let's see. So here's parallel, right? 2 lines in the same plane that never cross. Okay, yep, got it. We had skew. Skew was this. That was something different. Those are 2 lines that never cross, but they're not in the same plane. Okay. Perpendicular. What does that mean? Can you refresh my memory? If you had to define perpendicular, it's 2 lines that do what?
Never touch.
I heard something, but I couldn't make it out.
Never cross.
So they do, though. They do. So, well, these are parallel lines, right? Yes. This picture is a parallel lines, two lines that never cross. Skew lines are your other ones that never cross, but I want perpendicular. So how should I arrange these sticks so that they're perpendicular? Let me ask you this. Are these perpendicular? No, these are not perpendicular. Are these perpendicular? Hold on. Are those perpendicular? Yes. So if you recall, we did define them, but it's been a while since we've talked about them. Perpendicular lines are the two lines that intersect at exactly 90-degree angles. That's what we're looking for here. So that's what perpendicular means. All four angles are exactly 90, right? They have to be perfectly 90. That's how I get perpendicular. Okay, so intersecting just means that they cross each other. Perpendicular lines do intersect, that's true, but they do more than that. They intersect at 90-degree angles. See, that one's not right. There we go. Okay, sometimes kids think that perpendicular means that they have to be straight up and down and straight horizontal. They certainly, those are perpendicular, that's true, because all four of these are perfect 90-degree angles, but they don't have to be vertical and horizontal. They can be, but these are still perpendicular as long as I have 90s. That's what I'm looking for, these perfect corners. Okay, that's perpendicular lines. So now what I'm going to do, I'm going to grab my graph paper from before. I'm going to erase one of these lines, and I'm going to draw a perpendicular line to it, and we're going to take a look at what happens with their slopes, okay? So let me just erase this top one. I love these erasable pens. It really is. Look at it's so cool. Oh dear, except I'm messing up my paper here. Look at that, like it never happened. Oh, and my camera died again. Are you kidding? That's okay. I'll use its time while it's resetting to draw my perpendicular here. Okay, here we go. So I'm using my super cool ruler, which has all these really nice sharp 90-degree corners. So I lined it up just so that I knew I was making perfect 90s, and I created a new line here. Let me zoom in on it. Oh, you know what? I should have done it a different color. Hang on. Oh my gosh, the lines are so straight. Who'd have thought, right? I'd get so excited about a ruler. That's what happens when you turn into a geometry teacher. These sticks changed my life. I didn't know that they existed. I've only had these for like 2 years. I don't know. This is like my 100th year of teaching. How did I do the other 98 years without these? I use them all the time now. So convenient. Any Hoosers. Here we go. So let's take a look now. So I have a line that I know is perpendicular because I used a nice 90-degree angle to create it. And so this reddish line, can anybody tell me the slope of this sort of reddish line here? What's the slope of that one? Can you see it well enough? Maybe I'll try and zoom in a little bit more. Someone give me the slope of that red line there.
-3.
Yes, -3, right? So remember, when you're given a graph to find the slope, I'm just moving from left to right. Since I'm going down, I'm going to make my number negative. So I have to go down 3 boxes to the right 1, down 3 to the right 1. So the slope of this red line is going to be -3. Now, that's very interesting. That's very interesting to me. So look at these two slopes. They're not the same. Of course they're not, because if they were the same, they would be parallel lines, and I don't have that. But they sure are related. Do you see a relationship between these two numbers, this one here and this one here? What's the deal? What do they have to do with each other? Anybody see, or do you recall from algebra? I know that these are the slopes of two perpendicular lines. They're not the same, but what are they? Dig deep into the recesses of your brain. I know you remember this.
Don't you like flip it and then like add the opposite sign?
Yes. Yes. So there are two things that are always going to happen with perpendicular lines. Their slopes are what we call opposite reciprocals. That's sort of the magic words that we're going to use. Opposite means opposite in sign. So one's always going to be positive, one's always going to be negative. Okay? So I'm always going to have one of each, one positive, one negative. And then they're also reciprocals of each other. So if you remember, that's a fancy vocab word, which means take a fraction and flip it over, right? So if I take 1/3 and I literally flip that fraction over, don't I get 3/1, which is just 3, right? So I'm always going to be doing two things. I'm going to change the sign and I'm going to flip the fraction over. Oh, hopefully this is all kind of coming back to you from algebra, because I know that you learned this at some point. So that's our second really big firework for today. We are going to make sure that we have this down, and I went definitely the wrong way. There we go. So second big firework for today. Jazz it up however you like. Perpendicular lines have slopes that are opposite reciprocals. And that's the magic words that they're looking for. Opposite reciprocals. And I'm going to tell you right now, I would bet money that they're going to ask about parallel and perpendicular lines on the MCAS. I would not be surprised at all. They love to throw these things in there. They love to even do, if I remember right, because you can go online, I don't know if you know this, but you can go online and look at all the old MCAS tests. So you can go look and see, what was the math test in 2015. It's all online. You just go, it's all there. So you can, if you haven't looked at one yet, I highly recommend you go check one out, just so you know what to expect, right? Do you know? Do you have any idea? I don't know. So there's usually, I mean, this year is so crazy, but in normal years, there's one section that you do that's absolutely no calculator. They give you, you always have a formula sheet that you can use, but they're all ones that you could reasonably do without a calculator. Pretty straightforward. And it is sort of a smattering of all different things. There's some algebra, there's some geometry, there's, ones that you could figure out multiple different ways. And the first section is multiple choice. And then you have an open response section. So they might give you questions that are open-ended and you actually write sentences as your answers. So you do have to explain yourself, like, how do you know that these two lines are perpendicular? So if it was a question like that, they're going to ask you, they're going to be looking for you using these words. Do you know that opposite reciprocal slopes mean that you have perpendicular lines? I'll look and see tonight if I can find one similar to this. It's probably not that hard to, I'll go look. And then there's another section that you do have a calculator. And then I think it's the same thing, right? A multiple choice section with a calculator and open response with a, or am I wrong? Now I can't remember. I can't remember if you have multiple, Ms. Muska, do you remember? I know there's a multiple choice with no calculator and a multiple choice with, but is the open response with a calculator or not? Or is there one for both?
I think there's one for both.
Is there?
I think so.
All right, I'll look tonight. But any hoosers. So let me make sure I finish this, and then we can always talk about MCAS more later. But perpendicular lines have slopes that are opposite reciprocal. So here's what I want to do. I'm going to make a little chart. Here is my original slope. And then we have the perpendicular slope. So remember, the symbol for perpendicular is just that upside down T, capital T, right? So we just did one on our graph paper. The original slope was 1/3, and we found out that the perpendicular slope was -3. So you can see that they are opposite in sign. Yep, one's positive, one's negative. And then I just took this fraction and I flipped it over. And that's how I got 3. All right. So try this. Excuse me. Try this one. What if my original one was -2/5? What would the new slope be of a perpendicular line? Just shout it out if you know it.
5/2.
Yeah, I'm going to make it positive now because I started negative, so now I want it to be positive, and I want to flip it over, so I get 5/2 is perfect. Good. Okay, let's try another one. What if the original one, oh my gosh, these pens are driving me crazy. What if my original was -6? What would the new one be?
+6.
1/6.
Yeah, so it's not just +6, right? Because I still need to flip the fraction over. This is a fraction. It's just over 1 normally, so we normally don't write it. So if I'm going to flip it over, it's going to be a +1/6. Everybody see that? So yeah, be careful with those ones that are whole numbers. Let's see. Let's do, what if I had -1/9?
9.
+9, correct. Okay, now I'm really going to throw you for a loop. You ready for this one? What if the original slope was 0?
0.
Ooh, that's what everybody guesses. Yeah. Unfortunately, it's incorrect. Because think about it. If they were both 0, wouldn't that mean that they're parallel? Because they'd have the exact same slope.
Undefined.
Right? Ah, yes, it is undefined. So this is sort of a weird case. So I want you to put a star and sort of highlight this example here. These two go together for perpendicular. If one of them is 0, the other one is undefined, okay? And if you think about it, it kind of makes sense. If I have 0 and I'm trying to take the reciprocal of 0, doesn't that mean I'm then going to put 0 into the denominator? And isn't that how I get undefined? By putting a 0 in the denominator, right? So that's interesting. The sign, the opposite part really that part's a little weird because 0 is neither positive or negative. So how do you change the sign if it doesn't even have one? So that's why this is sort of an extra special weird case. And if you think about how the lines look, think about a line that has a slope of 0. Isn't it just a horizontal line? Right? Who has an undefined slope? Isn't that just a vertical line? And aren't horizontal and vertical lines perpendicular to each other? They are. So this actually kind of makes sense, right? If one is 0, the other is going to be undefined, and vice versa. So if I had one that was undefined, the perpendicular would be 0. Oh, tricky, tricky, tricky. Yes. So I can't ever have matching slopes for perpendicular. They have to be opposite reciprocals of each other. All right. So just like I did with parallel, I'm going to ask you the same things. I'm going to give you an equation, and now you tell me what is the slope of a line perpendicular to the following. All right, so we'll do a bunch of examples again. So we'll start off easy. Y equals, oh, I don't know, how about negative 2x plus 1? Then we'll move on to, I don't know, y equals 3/5 x minus 7. Five x plus y equals 10. And maybe one more. See if I can squeeze it in here. Okay, so I'm going to do the same thing like I did for parallel, but now it's perpendicular, right? So make sure as you're doing the homework, the first half is parallel and then it switches to perpendicular. So make sure that you're paying attention and you know what they're asking for when, right? Because it's going to completely change your answer, whether you're talking parallel or perpendicular. So I'm going to ask you for the original, and now I want the slope of a line that's going to be perpendicular to it. Okay, so let's try number 1. I still have a handful of you that haven't been called on yet. How could that be? Oh my gosh. Oh, look, I'm getting answers in the chat for all of them already. Look at you guys go. Sophia, number 1, can you tell me what the slope of this original line is?
Negative 2.
Correct. So what would the slope of a line perpendicular to it be?
1/2.
Positive 1/2. Correct. So that's my final answer. So on your homework tonight, you're looking for this number when they're asking for slope of a line perpendicular to, right? So there it is. All right. So I'm going to do the same thing here. I want the original, and then I want you to give me the slope of a line perpendicular. Okay. So on number 2, what is that original slope as you see it? Molly S.
3/5.
3/5. Correct. So what would the perpendicular slope be?
-5/3.
You got it. -5/3. Good. Oh, I'm so glad. Now, when you hit number 3 here, I hope you are not thinking, oh, the slope of the original is 5. No, it's not. Don't fall into that trap. You're going to get stuck there. It's like quicksand. I don't want you to get stuck in quicksand because I don't know how to get you out. Besides throwing you a branch. Here's the branch I'm going to throw you. You got to get it into y equals mx plus b. Right? So the only way to do that is to minus 5x from both sides. So what am I left with? Y equals, I'm going to stick that -5x right after the equal sign, and then I have the plus 10 on the end. Now I'm ready to finish. Okay, you can't bypass that step though. You have to do that. I don't want you to get all of these wrong. Now I can figure out what the slope of the original is and what the slope of my perpendicular is going to be. Okay, Olivia, what's the slope of the original now?
-5.
You got it. So what would the slope of the perpendicular be?
-5.
Careful. If they were parallel, you'd be right, but I want perpendicular.
1/5.
Yeah, positive 1/5. That's the ticket. And now my last example like this. This thing. I'm going to do the same. I want the slope of the original, and then I want the slope of the perpendicular. So I'll take a volunteer on this one. What's the slope of this original thing?
Undefined.
Undefined. Yes, this is a Hoy-Buck scenario because it's not in y equals mx plus b form, nor could I ever make it be. That's how I know it's Hoy-Bucks. So this is, I'm looking at the x, it is undefined. So what would be the slope of a line perpendicular to it?
0 slope.
Yes! If one's undefined, the other one is 0. Oh, I'm so happy. Yay! Okay, I have one last thing to ask you and then we're done. Okay, I got to flip this page, so I hope you got it. Last thing I'm going to ask you, you're going to see the last couple questions on your homework are like this. It's going to ask you, are the lines parallel, perpendicular, or neither? Oh, this is interesting. Let me zoom out here so we can actually see it. There we go. There we go. So for each one, you're going to be given two lines. Y equals, I don't know, let's say negative 4x plus 3 and y equals 1/4 x minus 7. So let's just pretend these are my two lines. And you choose between these three things. They're either going to be A, parallel, B, perpendicular, or C, neither. So here's how I would suggest you sort of go through this. Use process of elimination. Are these two parallel? Just shout it out, yes or no? Are they parallel?
No.
No, they would have to have literally the exact same slope, and they don't. So these two are not parallel. Are they perpendicular?
Yes.
Yes, look at their slopes. -4 and positive 1/4. They are opposite reciprocals of each other. That's what I need, okay? So obviously that's my answer. It's not neither because it was perpendicular. So if they're not parallel and they're not perpendicular, that's when I'm going to go with neither. But these were perpendicular. Okay, let's try another one. What if I had y equals 1/2 x plus 3 and y equals -1/2 x minus 5? Out of the same three choices, well, let's go down the list again. Are they parallel, yes or no? Shout it out. Are they parallel? Yes or no? No, they're not, right? Because these slopes are not 100% the same, are they? Positive 1/2 and -1/2 are not the same. So if they're not 100% the same, I'm not picking parallel. Are they perpendicular?
No.
No. They are opposites of each other, but they're not reciprocals. They have to be both of those things. They're not. So that means these are just going to be neither. They're just two random lines. They're not parallel. They're not perpendicular. They're just two lines. Just hanging out. Okay. So let me ask you one more. This one's tricky. This one stumped the other classes. So let's see if you guys can figure it out. What if I had x equals 6 and x equals -4? Same three choices. I'll even write them out this time. Parallel, perpendicular, or neither. Take a minute. Decide for yourself which of these three I have in this scenario. Decide for yourself. Commit to either A, B, or C. Have you committed?
Guys,
All right.
never commit.
What was that?
Guys never commit.
Well, I am going to give you a tiny hint, and I will allow you to change your commitment if you want. The 6 and the -4 literally have nothing to do with this. I don't know if that changes your answer. Okay. Does anybody think that they have the right answer and want to share it? Shout it out if you think you know.
Is it parallel?
They are parallel! Yes! Yes! I know what some of you are thinking. Miss Savia, you said parallel lines have to have the exact same slope, and 6 and -4 are clearly not the same thing. Right. That's not the slopes of these lines. If you're just thinking about the slope, that's a Hoy-Buck situation. Just look at x equals 6, right? What did we do every time we had that? We went to Hoy-Bucks.
They're
That
parallel.
thing has an undefined slope, doesn't it? It does. That thing's slope is undefined. It's not 6. 6 is not the slope of that thing. The slope is undefined. And then I do the same thing with this one. And I ask myself, okay, x equals -4. What's the slope of that thing? It's still a Hoy-Buck situation. It still is undefined. They both have a slope of undefined. If they have the exact same slope, you know the answer. They're parallel. Oh my gosh. Oh, that makes sense now. Right. 6 and -4 really have nothing to do with it because they're not the slopes. And all I care about is slope. I don't care about the other numbers. Ooh, I hope that makes sense. All right, guys. Oh, you were so good today. I'm so pleased. Let me go ahead. Does anybody have any questions right now? We're feeling okay? All right, let me stop.